Hello everyone, this is Dr. Prashant and welcome back to Biostatistics lecture series. In this video, I will discuss about the topic probability. Probability is the measure of the likelihood of an event to happen. It denotes the possibility of the outcome of any random event. So if you want to find probability of a particular outcome, we need to divide number of favorable outcomes by number of total outcomes. So let's understand this with an example, flipping a coin. So we know a coin has got two sides, head and tails. But if I want to see the probability of heads, the number of favorable outcomes in this case will be 1 divided by the number of total outcomes. It is 2. So the probability in this case is 0.5. Similarly, rolling a die, and if I want to see the probability of throwing a 3, so the favorable outcome will be 1 divided by, we know that die has got 6 sides, so the number of total outcomes will be 6. So 1 divided by 6, so the probability in this case is 0.167 or 16%. And now coming to probability in statistics, there are two concepts of probability. One is classical probability. So in classical probability, if an event can occur in n mutually exclusive and equally likely ways, and if m of those possess a particular trait E, the probability of the occurrences of E is equal to m by n. Whereas in relative frequency probability, if some process is repeated a large number of times n, and if some resulting event with a characteristic E occurs m times, the relative frequency of occurrence of E, m by n, will be approximately equal to the probability of E. So in this case, the probability of E will be m divided by n. Properties of probability. So there are basically three important properties. The first one is, given some process or experiment with n mutually exclusive outcomes or events like E1, E2, E3, so on till En, the probability of any event Ei is assigned a non-negative number, that is Ei more than or equal to 0. So probability should always be positive, it cannot be negative. And now coming to the second property, the sum of probabilities of the mutually exclusive outcomes is always equal to 1. That means probability of E1 plus probability of E2, E3, so on till En will always be equal to 1. And coming to the last property, consider any two mutually exclusive events, Ei and Ej for example. The probability of the occurrence of either Ei or Ej is equal to the sum of their individual probabilities. That is, probability of Ei or Ej, okay, either Ei or Ej will be equal to sum of their individual probabilities. So the individual probabilities will be P of Ei plus P of Ej. So before proceeding further, I would like to explain three important terms which are very important in the concept of probability. One is mutually exclusive event. Events that cannot happen at the same time. A simple example, throwing a die. 3 and 6 cannot happen at a time. 3 and 2 cannot happen at a time in a die. So these are called mutually exclusive events. And now coming to independent events. Two events are called independent when the value taken by the first event tells us nothing about the other and vice versa. Or the probability of event A is the same regardless of whether or not B occurs. So it's very clear, right? Two independent events. So the first event will not tell anything about the other and vice versa. And now coming to the last term, that is complementary event. When the sum of probabilities is equal to 1, or the probability of an event A is equal to 1 minus the probability of its complement A bar. So probability of A bar is equal to 1 minus probability of A, or in the other way, P of A will be equal to 1 minus P of A bar. Now I will explain the different probabilities using a numerical example so that it will be very easy to understand. So I have took an example where the frequency of cocaine used by gender among adult cocaine users was given. So there are 4 columns. The first column, the lifetime frequency use of cocaine, and in the next 2 columns it's the gender, male or female, and in the last column it's the total. Okay, so I have given a small note. We assume that male and female are mutually exclusive. So now you need to go back and understand the concept of mutually exclusive. So the male and female are mutually exclusive categories, and that the likelihood of selecting any one person is equal to the likelihood of selecting any other person. Okay. So to start with the basic probability, here the question is calculate the probability of males. It's very straight and simple, right? So how we calculate it? The probability of males, that is M, is equal to number of subjects with the characteristic of interest. What is the characteristic of interest in this case? It's the male divided by the total number of subjects or outcomes. So P of M will be The number of males divided by the total number of subjects. So go to the table and see what is the total number of males. Go to the male section and see the total below. It's 75, right? 75 divided by the total number of subjects. You can find it in the right last column under the total section, which is 111. So 75 divided by 111, that is 0.67 is the probability of males. So this is the simple probability or the direct probability. And now coming to second type of probability, which is conditional probability. So just understand the term. As the name itself suggests, we are trying to put some condition, right? In the first case, it was direct probability of males, but in this case, probabilities are calculated with a subset of the total group as the denominator. What does it mean? A simple example, suppose if we pick a subject at random from 111 subjects and find that he is a male, what is the probability that this male will be one who has used cocaine 100 times or more during his lifetime? So simply, instead of calculating the total males, we need to go to the males column and find how many males have used the cocaine more than 100 times. It's 25. 25 divided by what is the count of total number of males? It's 75, right? So 25 upon 75, we get the probability as 0.33. This is called conditional probability. And now coming to third type of probability, which is joint probability. In this case, probability that a subject picked at random from a group of subjects possesses two characteristics at the same time. So I'm using the word two characteristics. So that's why we call it as a joint probability. Simple example. What is the probability that a person picked at random from the 111 subjects will be a male and be a person who has used cocaine 100 times or more during his lifetime? So very simple. In the previous case, we have seen only the males, okay? Total males are 75. Among those 75, how many people used 100? But in this case, we want to see out of total subjects, for example, the number of males who used cocaine 100 plus times is 25. That is clear, right? Numerator divided by denominator. In the denominator, we use the total number of subjects because they are telling us a person picked at random from the 111 subjects, okay? So this will be the joint probability, and in this case it is 0.22. And now coming to fourth type of probability, which is marginal probability. It refers to the probability in which the numerator of the probability is a marginal total from a table. For example, probability of males, which we have discussed in the first point, right? The direct probability or the simple probability. So we call that as the marginal probability. The numerator of the probability is the total number of males. So let's understand this example. So in the below table, the category male, okay, go to the male column, okay, occurs jointly with all the three categories of the variable frequency of cocaine use. So there are two columns, male and frequency of cocaine use. So if I take the male category, it is occurring jointly with all the three categories of the variable, which is frequency of cocaine use, right? So the possible joint probabilities are male and A. What is A? 1 to 19 times. Male and B, 20 to 99 times. Male and C, that is 100 plus times. So the marginal probability will be, we know we can calculate the marginal probability directly by using the formula total number of males 75 divided by the total number of subjects. But what they want to tell us is that probability is equal to the different joint probabilities. That means male with different usage of cocaine. So let's see whether we get the same answer or not. So in this case, the probability of M will be male and A, male and B, and male and C. So you calculate probabilities of all the three. For example, male and A. Go to the male column and see how many people used 1 to 19 times. It's 32, right? So 32 divided by 111. Similarly, 18 divided by 111, 25 divided by 111. So we get the probability as 0.6757. So now go back to the first probability, see the answer, it's 0.67, right? So that is called marginal probability. We need to, check the relation of one column with the other column. And now coming to probability rules, the first rule, multiplication rule. In this, a probability can be computed from the other probabilities, okay? I mean, that is kind of indirect calculation. For example, joint probability of male and a lifetime frequency of cocaine use of 100 times or more, that is C, can be calculated from the marginal probability and conditional probability. How? Let's see. probability of male and C, that is 100 plus times use of cocaine, is equal to probability of male, okay, multiplied by probability of C bar M. What does it mean? So we know the probability of M, right? Because we have calculated in the first step, that is the direct probability, that is 0.6757, that is multiplied by, we also calculated probability of C bar M in the previous step. Okay, I'll just show it. Okay, so in this case, which is conditional probability, we know what is conditional probability, right? We put a condition. So now you multiply that and you got the value as 0.2252. So there are two general rules. If you want to calculate the probability of A and B, the formula can be probability of B multiplied by probability of A bar B. And if probability of B is not equal to 0. Similarly, P of A and B is equal to P of A multiplied by P of B bar A, if P of A is not equal to 0. So what does it mean? For example, in case of independent events, okay, P of A bar B is equal to P of A, because event of one will not tell anything about the other, right? And similarly, P of B bar A will be equal to B. So accordingly, the rule change here, we substitute P of A bar B and P of B bar A with P of A and P and B. So the rule will be P of A and B will be P of A multiplied by P of B. So this is a very important question. Many times they keep asking this in exam. In case of independent events, what is the rule of probability? What is the multiplication rule? So what generally people do, we get confused. Okay, so be clear. In case of independent events, the rule will be P of A and B will be equal to probability of A multiplied by probability of B, because the probability of A bar B is equal to P probability of A, and the probability of B bar A will be equal to probability of B. And now coming to second rule, addition rule. Probability of occurrence of either one or other of two mutually exclusive events is equal to sum of their individual probabilities. So let's understand this with an example. What is the probability that a person picked randomly will be a male or female from the whole data set? Okay, so we write the equation probability of male or female is equal to sum of their individual probabilities. Okay, we have already discussed this in the rules of probability, right? So properties of probability. So the equation will be probability of male or female will be equal to probability of male plus probability of female. So we will just calculate the P of M. We have already done it, 75 divided by 111 plus. Now we will calculate for female. Just go to the female. What is the total number here? It is 36, right? 36 divided by 111. So in this case, the probability is equal to 1. Thank you.